Hello. We welcome you back to PSSB, Physical Sciences Silver Bullet. Okay, today we are having this case. It says consider the equilibrium. This is the equilibrium. Initially, these are the number of moles of dinitrogen oxide gas, which is sealed in the 2 cubic decimeter container and heated to 100 degrees. At equilibrium, it was found that 35% of dinitrogen oxide has decomposed to nitrogen dioxide. And the question says, calculate the Kc value at this temperature. Yeah, like we always do, we urge you to subscribe if you haven't yet done so, and to call a friend, refer a friend to this very important channel. Okay, what do we do here? Okay, let's use this approach. We are having the equation. We are going to put it there. What comes next is mole ratio. Then next we are having initial number of moles. Okay, next we are having a change in moles. Then next we are having moles at equilibrium. Okay, let's make this one short. At equilibrium. Next we have what? Concentration. Okay. So because of our formula, we're going to divide this one into only, because of the equation, you're into 2. Okay. So for the equation, what do? You put them the way they are. It's going to be nitrogen, dinitrogen oxide, and we're having 2 nitrogen dioxide. The ratios are shown there. It's going to be 1 to 2. Initial number of moles are given, which is 0.94. And we have to come back and check, is the reaction just starting? Yes. There is this keyword here, we must not ignore it. It says initially. So what does that mean? That this side you have 0 because the reaction is just starting. And if it's just starting, what do we know? This one is minus, this one's a plus, because initially there is only one direction for the move, for the equation, that is forward. There's no product to react to from the reactants. Okay, then they said we're having this, they said 35%. So we are given our percentage which decomposed, and also this one is very important. 35% has decomposed. So what do we do here? The best approach for this one is to know how much remains at equilibrium, because initially if it was 100% and 35% decompose, what do you remain with? You remain with the 65%. So the number of moles at equilibrium is 65% of the initial. So what do you do under this circumstance? You say 65% of the initial. What do we get? This is what we get. So this is what you get after computation. It is 0.611 moles. So these are the number of moles at equilibrium. We put it here. It is 0.611. Okay. Remember what we experience. We say that this one is a minus. So 0.94 minus 0.611, you get those number of moles which decomposed. Okay. So we subtract and we get the answer. So we have those number of moles which decomposed. Now you have to remember that what controls this, these number of moles are controlled by the ratios. So what do we get here? Okay, yeah, the ratios are 2, so we're going to multiply this one by 2 to get the answer there. So that's what you get after multiplying by 2, 0.658. Okay, and remember these ones are increasing, so it's going to be 0 plus this. What do you get? 0.658. Okay, then what comes next is to get the concentrations by dividing with the volume. We must not forget that concentration C is equal to N over V. So what are you going to have here? 0.611 divided by the volume, and the volume is 2. The sum applies here is going to be 0.658 divided by 2. What you get out of this one will be the concentration, which you are going to put in the expression. So these are the concentrations we get after dividing by the volume. So what comes next is the expression. We have to remember that case expression is equal to the product raised to their power, which is NO2 squared, over N2O4. This one will give you, what's the concentration? It will give you 0.329 squared divided by what? 0.3055. And what you get will be your Kc. So after substituting in expression, this is what you get. So this is our Kc which we have obtained. Okay, thanks very much. We appreciate your time. See you next time. Bye bye. The channel is PSSB, Physical Sciences Silver Bullet. Thanks.